Thank you so much. The next speaker of the day is Mr. Ram Chinta, Director, Engineering for Cloud Platforms Group, Citrix. Ram Chinta joined Citrix through the acquisition of Cloud.com. Ram started Cloud.com's India Development Center and currently heads CloudStack Engineering in Hyderabad. Prior to Cloud.com, Ram held engineering roles at various distributed internet and mobile computing companies, including Netscape, OpenWave, Seven Networks, and Microsoft. Ram holds an MS in Computer Science from Iowa State University and a BTech in Computer Science from JNTU College of Engineering, Hyderabad. His topic today is architecting Amazon-style, agile, and massively scalable infrastructure as a service clouds. Ladies and gentlemen, please welcome Mr. Ram Chinta.
Good afternoon, everybody. Just a quick poll, right? How many of you here have used Amazon or Amazon-like service, right? Either as a programmer or a consumer, right? Good. So, like I'm Ram Chinta, just introduced. So I actually come to Citrix fairly recently through the Cloud.com acquisition, right? At Cloud.com, we've been kind of doing the CloudStack product, right? And building clouds for the last 3 years. And much of the things that we talk today is actually based out of the experience over the past 3 years, right? And the topic today specifically centers around building Amazon-style clouds, right? Because we've heard about clouds of different forms and different nature. We're kind of going to focus on Amazon style, what it means to be an Amazon style cloud, right? And what is the architecture that actually helps you scale and evolve, right? And how to incorporate that into your practice when you actually want to go build your own cloud. So often, right? I mean, in the last 3 years, when we go talk to customers, or customers often come to us, right? Hey, saying that, hey, we have implemented some kind of, virtualization in our center, right? We have either Zen server, VMware or Hyper-V, and there's some amount of automation that's already happened on top of it. Do you think I have a cloud, right? Yes, and maybe no, right? Yes, in the sense, yes, it's some form of cloud, right? But then, the question is, right? What do you want to get out of it, right? And are you ready to be able to evolve and take it to the next level, right? That's really what this is about, right? If you look at it, Amazon, right? Amazon has been doing this for 6 years now, and it's been fairly successful, right? So it's actually right now at $1 billion revenue run rate just from the cloud business. So obviously they're doing something right. And also if you look at the adoption, most of the CIOs today are thinking about building clouds. I think it's kind of become the top 1% priority only in the last 2 to 3 years. But if you look at the developers and actually the developers within those companies itself, they've been actually adopting and using cloud, the Amazon-style services or Amazon services for the last 6 years. So in fact, the CIOs have been behind. Actually, the adoption has been happening, from the grassroots level, right? And only now the CIOs have woken up and kind of saying, hey, what do I need to do to kind of get that kind of a thing in-house into my enterprise, right? So the question finally, goes down to, hey, what does it mean, to build an Amazon-style cloud, and how is it actually different from the server virtualization that I've been doing, right? I've done some bit of automation. There's a bit of self-service already in there, right? But then, how is it different? What do I need to do next, right? So the first thing is, let's go back. I need to kind of answer that question. Let's go back and look at how Amazon themselves have actually built this IaaS cloud, right? If you look at it, the first thing they've taken is got a lot of commodity servers, right? Commodity networking devices and storage. They haven't really gone for the high-end devices, right? Anywhere, either storage or whether you look at the servers, anywhere, right? And the next thing they've done is kind of got the open source Zen hypervisor, right? On top of it, this is where a lot of the intelligence comes in, right? They build a orchestration platform or orchestration layer, right? And that actually does a lot of this management and placement of things, right? And then they've exposed an API, right? The AWS S3 and all these other APIs. So the key thing is the API, because that's actually opened up the whole power of this whole infrastructure to the programmers out there, right? Everything can be automated, right? You don't have to actually physically have access to it. You don't have an IT, admin, IT, department on the, kind of managing all of this. The consumer is directly empowered because of this, right? And then on top of it, Amazon built its own e-commerce, the whole services that are on top of it, right? So, so now getting, so now that again, right? So what does it mean, right? How is it again different from the virtualization or enterprise virtualization that I've already implemented, right? So if you look at it, right, the enterprise, the so-called enterprise virtualization, it's all about managing server pools, right? But the thing is, does it scale? How much does it scale, right? It typically scales to a couple of pools, a couple of clusters, maybe to hundreds of servers, right? Then, but whereas, when we're talking about Amazon-style cloud, we're talking about a magnitude of thousands and tens of thousands of servers. And the other thing is, what about the management aspect of it? Typically, the enterprise virtualization we're talking about, right, is about, you probably have one admin for about maybe dozens of servers, right? Whereas when you're talking about, Amazon-style cloud, it's like thousands of servers. And, and the other aspect is, the automation side of things, right? So, the whole thing about, metering, self-service, right? The ability to integrate with your other applications and the ability for the programmers to go automate the infrastructure, right? All of that is extremely important for the adoption and actually the uptake of the infrastructure that you have gone and put out there, right? And that's again something that's very unique to the way we're talking about the Amazon-style clouds. And finally, right, it's also about proprietary hardware and lock-in and so on, right? The typical, the old, the enterprise virtualization tend to be kind of go with sophisticated hardware. Think of high-end devices, and the scaling is usually happening vertical, right? Whereas here in the cloud, right, in the typical Amazon cloud, we're talking about horizontal scaling, right? And then we're talking about commodity, right? So you don't necessarily have to go buy the high-end, equipment. You just go build things out of the one. And the other key difference is the ability to deal with failures, right? In the, that's again, we're kind of going to kind of spend a little more time, later in the talk, actually. So just to summarize the things that we talk about, right? So elasticity and self-serve, I think we all come to accept that, it's something that we, very essential and basic about, any cloud that we're trying to, we've come to accept that right now in the last couple of years now, right? But the key things are the other aspects, which is the massive scale, the ability to automate the APIs, right? And the ability to deal with failures being, when I mean self-healing, right? The ability to kind of, deal with failures and how to kind of work through it, right? The total homogeneous, right? I mean, just to kind of, delve into that part, right? So when you're building racks, right, or when you're building, these cloud infrastructure, right? As an administrator, right, when you're adding new capacity, you want to take off the shelf, right? Existing templates, existing way of, adding capacity should be pretty straightforward, right? You don't go build custom hardware, custom templates, and so on. Just, let's say in the case of a managed service, that's considered to be very common, and that's something you do all the time, right? Whereas in this cloud, right, you're talking about, you want to go add capacity. It's just going about, adding a couple more of those commodity racks or commodity servers that we talked about, right? All the commodity hardware. So pretty much, I mean, if you look at the way, like as we discussed, Amazon-style clouds have become so popular, and in the early adopters were all the service providers who wanted to offer, Amazon-like services, right? In India, we have Tata InstaCompute, right? There are a lot of other customers, other, service providers out there as well, right? But of late, if you look at it, right, there's a lot of enterprises who are actually adopting Amazon-like actually clouds, right, for their own internal consumption, right? If you look at it, there's quite a few out there, and that's just, at least that's working in progress, right? I mean, that's already have adopted. Rather, there's a lot of guys, a lot of enterprises that are still in the pipeline, right? So, Bechtel, I don't know if you guys are familiar, but it's actually one of the big top 10 engineering companies in the world, Nokia, right? And, Hokkaido University, right? It's actually a group of 6 to 7 universities in Japan, right? They're actually considered to be one of the, the brighter universities in Japan. So they've actually kind of teamed up, 6 or 7 universities to kind of create a cloud that can be utilized for their researchers, their students, and everybody, right? So, and here you don't see Zynga, right? Zynga actually, if you look at it, they recently shifted 80% of their workload. Initially, they were all of their games, actually they were on Amazon. I think over the last couple of months, they've actually shifted 80% of the workload to their own internal cloud, right? Which is again an Amazon-style cloud, and 80% of that has actually moved to their internal cloud called the Z Cloud. So now getting to the next level, right? Hey, so fine, I understand what does it mean to be an Amazon-style cloud, right? So, but what is it that makes it scale, right? So if I want to go build an Amazon-style cloud, what is the architecture that I need to adopt? And how is it that this architecture actually helps me scale and extend, right? So when I say extend, it is about extending and embracing, right? You already have certain investments in your server virtualization farms, right? So how do I go, right, actually manage and incorporate and embrace that aspect also, right? And the other thing we said, which is very different in Amazon-style cloud compared to a more traditional enterprise, virtualization is about the failures aspect of it, right? That again, we're going to spend a bit, into that aspect as well. So let's take a quick look at, what a Amazon-style, right, zone looks like, right? So this will kind of help you understand why it scales well, right, and how it compares with your traditional, server pools, right? So if you look at Amazon, right, there's this notion of pods, right? If you can see it, right, the vertical ones, right, where you have this is more like your typical server pool. You have a bunch of servers, right, working together, right? And then there's a top of a rack switch that actually, takes care of the networking for that switch, right? Sorry, for that pod, right? And so the first level of scaling happens where you can actually keep adding servers, right, to a particular pod. We are talking about the physical infrastructure, right? If you're going and building an Amazon-style cloud, right? And then, you can keep, let's say you've gone beyond that capacity, you keep adding pods, additional pods, and then you keep adding pods, right? And then this forms what is called a zone, right? And this you can think of it as a data center, right? With the traditional, way of traditional thinking, right? So basically, this is more like a data center. A data center or a zone is, you can think of it as physical level of isolation, physical, separated, right? You can actually have multiple data centers or multiple zones in the same geography, or you can potentially have them distributed across geographies, right? So that's how you can keep scaling, right? And the other thing is, if you look at it, there's a core switch and load balancers as well, right? Because these are the ones that actually help you get the access to the outside world for the compute infrastructure that's there in your zone basically, right? But if you notice here, we haven't put a firewall in there, right? Strictly speaking, a firewall could have been there. So for all the VMs or for all the compute resources that are there inside the zone, they could potentially use the firewall, right, for all the access, right? They could potentially program all your firewall rules in there. But you know what? Frankly, that doesn't scale too well, right? So you could take that approach, but there's also other ways of doing it that are potentially more scalable, right? So this goes back to what we discussed, right? You take one zone, right, and then you want to add additional capacity either for redundancy, failover, or just for adding additional capacity, right? So you can so for example, Tata has a couple of data centers, right? One in Hyderabad, one in Singapore, and so on, right? Amazon has it in the East Coast of US, West Coast of US, Singapore, and so on. So, and usually, typically, what happens is, right, there's some level of, typically the zones are, fairly separated. The resources are fairly separated, but potentially the applications can make use of what you call do some DR and redundancies using storage cloud, or what is in Amazon world, right? The S3, right? You can actually take advantage of object repositories that are actually available across zones and use that for your DR and backup mechanisms, right? But the key thing about this is, see, the reason why this works very well, the storage cloud or the so-called object store, right? Much of if you look at it, you only have objects that do not change. Once you put an object there, it doesn't change. That actually reduces the complexity several times, actually, right? So now what Amazon has to do is make sure the same object is actually replicated and stored in several data centers so that there's no loss of data, right? So because there's no change, it's actually much easier for them to go and implement this, right? And if you look at it, Amazon actually offers 11 nines of guarantee that your data will not be lost, right? And majority of that is actually because they've actually kind of minimized or reduced the complexity of the problem, and that actually works quite well if you look at it, right? So this goes back again, so the thing that we just discussed, right? We have multiple availability zones, right? Being managed. Sorry, I still have a reference to CloudStack here, but CloudStack is our product. But you can think of it as any orchestration platform that can do this kind of orchestration, right? So you have multiple availability zones being managed by one management server, right? And then you have an object store that can be used to kind of share resources or objects across zones. And the scaling works so well, right? For example, in a couple of our deployments, you actually have one management server deployment actually managing 10,000 hypervisor nodes. So the scale, the scaling of the orchestration layer or the management server itself can be quite large, right? So going, if you delve, a little further, again, goes back. Remember, if you go deeper into the availability zone, right? We discussed what we saw there, right? We have the server racks, right? We have the block storage. The block storage is basically the storage for your VMs. Remember, that's different from the object store, right? Object store is for actually putting your consumer or the user data, right? User objects, whereas the object store is for your actual volumes that you use, for your VMs. So this is good, right? Now we build a Amazon-style cloud which scales, right? Often, of course, there's one more question, right? Often there's also this question comes up, hey, I'm trying to do this for my enterprise. Why do I need this level of scaling, right? I mean, I'm happy with my 100 servers, right? Or maybe 50 or 100 servers that I already have with server virtualization, right? Maybe that's true. Actually, that's why it's not a solution that everybody needs to write. There's no right or wrong answer. But very often what happens is you start with a very small cloud because you start kind of migrating workloads from a typical enterprise virtualization onto the cloud, right? So often you start with a very small cloud. You don't really need a huge, large cloud, right? But very soon, right, you'll realize, as you keep migrating applications, as the workload increases and as the adoption increases, you'll see that very soon you're hitting your limits, right? So you would much rather start with an architecture that will help you scale in the future, right? And the other part is, hey, does it cost you more? Probably not, because you're actually dealing with, commodity servers and everything, right? So it's actually going to be cheaper, right? So the next question is, hey, good, I've built my cloud, right? Amazon-style cloud. Hey, but what about all the investments I've made, right? I do have a couple of applications, working, in there with my old virtualization, server virtualization, or the enterprise virtualization model, right? What do I do with them? So you have the new or the cloud that you built, right? And you also have a couple of workloads sitting there in your old, the virtual, enterprise virtualization style cloud or a pool, right? So the good thing is go pick a solution that will actually help you manage both of them, right? So you can actually, what you could do is, remember we talked about the notion of zones, right? You can actually go make this a zone, right, of your whole, the Amazon style cloud the cloud that we are talking about, right? So that way you can actually go, the same management infrastructure, the same orchestration layer can actually go manage the cloud that you've just built, right? But you can also go manage the infrastructure that you've already put out there, right? So that will be a good, middle ground until you actually migrate, right, those workloads to a more typical cloud. So this is good, right? This we talked about how the architecture helps you scale at different levels horizontally, right? From a hypervisor node to a pod to a class to a zone, right? And to multiple zones and so on, right? So what about networking? How does it work? Because ultimately, again, networking can also be a bottleneck. If you don't really plan for it, right, it can potentially come back to kind of, So if you look, how does it happen today, right? If you look at Amazon Cloud, right? So there actually, you have, this one model, right, where everything is flat out there, right? So in a typical enterprise, you have multiple networks or VLANs, right? And you have a web server farm, right? Web server layer, then you have a database layer behind it, and you have a firewall sitting in the middle. So you have this typical three-tier model. So what happens when we kind of take that and go to an Amazon-style cloud, right? So what happens is you have your server farm, right? Then you go launch a VM, right? So you have your web VM, so it's able to take your load, right? Then the load increases, you add one more VM, right? Add one more. And then you have your database VM, right? Because you have your database sitting behind it, right? And then you get more load and you added more VMs, right? Web VMs, right? And then, accordingly, you had to add one more database VM. Good, right? You were able to scale. It was very elastic. That's good. But what about the security and the firewalls that we are traditionally used to, right? Because we had a tiered, approach before, right? The database was never exposed to the outside world, right? Only the web VMs were exposed to the outside world, not the database. But here, everything is right there, out in the open, right, in a very flat network. So this is where we have the notion of security groups, right? So you put all the databases into one security group, right? And then all the web VMs into another security group. And then you have your policies there saying that, hey, for the web VMs, I'll only allow traffic from the outside world, right? Or rather, I will allow traffic from the outside world on certain ports, right? But whereas for the database VMs, right? Sorry. It's okay, I think. So for the database VMs, right? So you need to kind of have policies in there so that only the web VMs will be able to access it, but none from the outside world. So what is that how is that different from the tiered network, right? Because if you look at it, we have still been able to kind of get that same security levels, right? But at the same time, we've done that in a flat network. And the reason why that's important is by having done in a flat network, all of these firewall policies or security policies, we have been able to kind of automate and enforce them at the hypervisor level, right? That's what the data security groups do, right? They're not getting programmed into the firewall, right? The external or a physical firewall, but they're actually being enforced by the hypervisor. And remember, this is all happening automatically still, right? The orchestration layer goes and programs those, those rules onto the hypervisor, and usually that's done by using, the EB tables or IP tables and so on. But the key thing is it's happening in the software, and it's happening at the hypervisor node. And as a result, you are able to scale to thousands, sometimes. In fact, like we talked about Zynga. I think that's what they do, right? You can actually scale this to thousands and thousands of servers and VMs, basically. So now let's contrast that, I mean, we just talked about having multiple tiers, right? In a traditional, typical, architecture, you have the web layer, then you have the database layer, right? And usually what happens in there is you actually use VLANs, right? You do VLANs for isolating the networks, right? Even though they are all on the same, right? So this is what, right? So what happens is if you have user one on one particular farm or a rack or a pod, whichever you look at it, right? And you have VMs of that same user spanning across different pods, right? They all get trunked onto the same VLAN, onto the switch, right? As a result, they're all isolated, and they get their isolation, achieve their isolation that way. And that's a very standard model, and to this day, it's quite popular. Even in the clouds that we have built, majority of the clouds still use this, right? So, and then you have user two, right? He will be, allocated a different VLAN, and there's good isolation because of that, right? So good, then what's the problem with this? Because, this is another way of doing this. There's nothing wrong. It's actually quite decent. And today, majority of our customers who have actually built clouds use this model as well, right? So, sure, and the big reason is, right, if you look at it, right, the number of VLANs that can be, supported in hardware is only 4094, right, because of the 12-bit, the VLAN tag, right? But again, for a lot of enterprises, that's still good enough, right? But if you are ever thinking about scaling beyond, right, this model would become a issue, right? And right now it's not, but very soon it will be, right? So how do we work or go beyond, this kind of a limitation? So this is where, if you look at it, right, here again, I think, going to software helps, right? So what you do is, software, you do your networking in software, right? What you do is, let's say in this case, you have 4 hosts, right, for user one, right? We have VM 1, 2, 3 on 3 different hypervisor nodes, right? So what you do is use, open vSwitch, or, there's a lot of other solutions out there, right? Even VMware distributed vSwitch, or, there's a lot of other, actually startups doing these software switches, right? So what you do is, you kind of use that, right? And then, the so-called orchestration layer, right, acts as a controller for this, right? What it does is, hey, I have a VM on host 1, host 2, and host 4. So what it does is it goes and establishes a GRE tunnel, right, between the 3 hosts. So basically, it establishes a GRE tunnel, right? And thereafter, so basically they get isolated, right? And effectively tomorrow, right, we have another VM come up there, so it establishes one more tunnel over there, right? So now what happens if you have a second? So if you have another user, one user is in purple and the other in blue, right? So you use the same GRE tunnel, but you use different keys. So effectively, it's very similar to VLANs. It's just that it's all happening in software, right? So you achieve the same level of isolation, right, on your network using software. And the best part is it's able to scale. You don't have that limitation of 4094 anymore, right? The 4094 suddenly becomes, how many, right? Because it's a 32-bit, right? You actually are able to scale much, much beyond. So I think I'm running out of time. So I think the last part I wanted to touch upon was the failure aspects of it, right? If you look at it, right, if you look at this traditional virtualization or server virtualization architectures, right, they're all centered around building sophistication or redundancies into the infrastructure, right? So you do multipathing, bonding, right? You kind of put all of that, right? HA, VMHA, all of those into this, right? But if you look at the cloud, right, if you want to go, one option is to reduce that complexity there, right? And if you look at Amazon, right, that's what they do. And if you look at, and they're quite popular as well. There's a lot of workloads moving there, right? So it works quite well. So you actually are, instead of relying on the underlying infrastructure to be bulletproof, which is never going to be, because how much ever investment you put in there, it can never be, right? It's much rather move that intelligence into the application, right? You take your backups, right? Assume that, make your applications more failover tolerant, failure aware rather, right? And then, I don't know if you've heard of Chaos Monkey, right? Netflix, if you look at it, right, they actually run their service on Netflix, on AWS, and they have this so-called Chaos Monkey that goes and, randomly keeps shooting, their resources and instances, right? The whole idea is to have your application be tolerant and be aware and be able to cope with all these failures, right? That's the trend, that's the direction that most of these things are going, right? So I think I'm going to skip some of this, but once you have actually built your cloud the way you want it, right, the next thing is, hey, what do I do with my apps? How do I move them there, right? We discussed the architecture fundamentally is different. So largely speaking, most of the applications do work, but there are some traditional, enterprise applications that may not work as is, right? You probably have to go tweak them, change them a bit to be able to get onto the, the new style clouds, right? So, these are typical workloads that you can, start shifting to a kind of cloud that we talked about, right? So, just to conclude, right? So, what do we do, right? I mean, just to summarize all the things that we talked about, right? So, you start building Amazon-style cloud first, right? And incorporate your investments that you've already made. You can still manage and orchestrate your existing, workload, right? And then choose the right architecture for your target workload. So there are certain workloads that will, that are kind of very friendly and natural and normal to work on this new cloud, right? But there are also going to be the old traditional, workloads that will probably have to be gradually, migrated onto the workload, right? So that's what we're going to do, transform existing apps to fit Amazon-style cloud. So I think just to conclude, right, I just want to just 1 minute about where Citrix fits in, right? So far, I try to stay away from the product specific, but so we just go back to the stack that we discussed, right? If you look at the way Amazon, the stack looks, right? We had this, commodity servers with a hypervisor and a orchestration layer with APIs and the business layer on top of it, right? If you look at, like as I said, I come from cloud.com, right, and Citrix. So here at Citrix, we have actually, we've taken this step further. We have kind of taken a similar viewpoint, right? And the difference is because it's a commercial product for anybody, right? The key thing is we support any server, right, any storage and any networking. And the other thing is, even with the virtual and the hypervisor layer, right, we actually support all the hypervisors, right? ESX, right, Xen server, OVM, Hyper-V, right, and all of those, KVM. And then we have what is our product, which is the orchestration product, which is called the CloudStack, right? And then we have the cloud APIs, right? Here again, we've been kind of, trying to be similar to what Amazon does. And then we have the cloud portal, which is a business manager product. And finally, I don't know how many have you been following CloudStack, right? CloudStack, has recently been donated or it became part of the Apache Foundation, right? It joins, some very successful products out there, right? The Apache Web Server, Tomcat, Cassandra, NoSQL, right? And Hadoop and all of these projects, right? There's quite a big community out there. And I think it's only been a month since it's actually, CloudStack has always been open, but I think in the last 1 month or so, it's actually joined the Apache Foundation. So there's a lot of momentum out there. So if there are people who are actually eager to go contribute, right, even in the open source community, you're encouraged to go try it, and also maybe contribute. Thank you. So if you have any questions, please, sorry, I probably took a little more time.
Oops. Questions, please. We have time for about one or, yeah.
Sure.
One, the mic's there, please.
Hello?
Yeah.
Hello?
Sorry, can't hear.
What happened? Can you just attempt to ask that without microphones, maybe? I don't
Hello?
know. Mics.
You have mentioned that there is a limitation of VLAN 4094. For that, there is another technology called, double stacking or Q in Q. Instead of using Q in Q, you adopted the software level GRE tunnel. Can you explain that?
No, you're absolutely right. I think there is some initiative towards that. And let me tell you, what I've said is just one way, right? But definitely there's more and more things happening. I mean, eventually that will, see, look at it, right? Any innovation initially happens in software, right? And very soon, a lot of those things start getting into the hardware as well. So I'm not saying, I'm sure there are other things going on, right? And there's some initiative going on, to extend that VLAN thing as well, right? I agree with that. There's more things coming. But this is something that's already out there that can be done today, right? And in a reasonably consistent way.
Thank you.
I have a question about the networking component.
Sure.
One of your slides you showed the server interconnect going through a bank of switches which are running software-defined networking, SDN.
Right.
There's a lot of buzz right now around SDN and OpenFlow.
Sure, that's why I didn't use that term too much here. So I tried to stay away from that. Go ahead.
What do you see the natural progression of that? Do you think that this is just a fad that will just come and go, or do you think that this is something that is here to stay?
No, I think it's going to pick up actually, right? Especially with this kind of infrastructure that's going out, right? People do want to have a consistent way of doing things. And if you look at it, a lot of the vendors have also started to adopt, right? So at least from what they read and from the momentum that we are seeing, I think it's bound to stay. I mean, we'll kind of know better in the next few months, but definitely there's a lot of activity going on the partner front, a lot of customers, a lot of partners actually coming and doing a lot of this work around there, right? So it does seem real right now.
Hi, Ram here from IBM.
Yeah.
When you talked about any platform, any hypervisor, any storage, do you support Power VM hypervisor from IBM, and for what?
Because see, we are driven by customer requests, right? But if there are people out there willing to contribute, I mean, that's very much welcome, right? Coming to storage, I think if you look at the way we do storage, right, we don't, it doesn't matter what infrastructure or what is underneath, right? We primarily use, iSCSI or NFS, right? The more standard protocols, right? So it doesn't matter if, irrespective of what the underlying infrastructure shouldn't matter so much to us, right? So potentially you could use Gluster or something else in the future as well. I mean, in fact, there's some, effort going on. So it doesn't matter as long as we kind of support those protocols.
Thank you.
Thanks, Ram, for that wonderful talk. I'm afraid we have time for just that much. And on behalf of UBM and Cloud Connect, we'd like to offer you a small token of our appreciation.